glimpsing into the future live. This is Rackspace's continuing coverage of TechCrunch Disrupt 2013. Now here's Robert Scoble.
Hey, I'm Robert Scoble, and you're here at the Rackspace Startup Zone or Studio at TechCrunch Disrupt 2013. We're all day long we're interviewing interesting innovators who are playing with the future, trying to build the future actually. Most of them are building for Google Glass, but we've had a variety of different companies on the set here. Anyways, we got another one who's building something for the camera that'll look at the sentiment of people that's looking back at you. So let's get into it right now. Who are you?
I'm Catalin Voss. I'm a student at Stanford, and I'm working on a company called Senshin, which I started while at Stanford, originally from Germany, and then spent some time out here basically building face tracking technology that we use in the education space to make videos interactive. And we kind of found that basically by porting a very, very lightweight face tracker to glass, we could basically train basic emotions on other people looking at you, and thereby help people with medical disorders and help people with autism.
Well, this is important for me because my 6-year-old son's autistic, and he has a few problems because of autism. One, he can't look in your eyes, so it's really hard for him to look in somebody's eyes for a long period of time, and that's an important social cue that we rely on to build trust and friendship and all that stuff. But then he can't read, are you getting angry, or are you happy, are you sad? Partly because he's not even looking at you, right?
Yeah.
But partly because his brain is just not good at picking up those social cues, and that keeps him from really interacting with people well, right? Sure. So I expect that by the time he's 20, where he's going to be in school, he's going to have something on his face like this Google Glass that's going to help him live his life and help him integrate into society better. Is that right? Is that where you're thinking?
I think that's sort of what we're envisioning. I don't know if it's necessarily about wearing it all the time and wearing it every day.
I do, so why not him?
It certainly might be. Exactly. Like for you, that might be totally comfortable. I don't know about everyone else. There might be people who would rather wear it for 3 months and go through some sort of training. Kind of the problem with, and I guess you must know this, the way kind of people like your son learn on emotions right now is they do it in almost a lab-like setting.
Yeah.
Right? They do flashcards, they do some games, they do, sometimes they bring relatives, they look at photos, but the way I smile and the way you smile look very different.
Yeah.
And what we were doing is we're trying to solve those two problems as kind of two steps. The first step is, helping autistic patients actually recognize emotions in other people's faces, and that's just kind of going off the outward glass camera. It'll tell you when I'm looking at you, or as long as you're in my view field of glass, I don't even have to be fully looking at you.
Yep.
It'll tell me, it'll find the face, it'll pose normalize the shape in the face, so it doesn't matter kind of which way you're looking, and it'll tell you happy, it'll tell you sad. And the second step is kind of how to respond to that. And we're focusing on the first one right now, and that's kind of where we think glass has a lot of potential.
Yeah, it's really interesting. So you're just using the outward-facing camera. You're not using too many of the sensors other than the camera right now, right?
No, not right now. So we might eventually get interested in using sound as well. That's kind of a component to that. So, but that's, we're a computer vision company. We started out building face tracking technology in order to make educational content more interactive, in order for devices to become more responsive to kind of how you look at them and how you interact with them. And glass is a natural extension of that interface was. But that's what we're focusing on.
Yeah, it's going to be interesting to watch as developers like you use the different sensors. For instance, there's an eye sensor that's watching where I'm looking, right? It's a crude eye sensor right now. It's 16 by 16 infrared eye sensor watching my pupil. But you could match that up with your app to tell whether my son's looking back at the subject he's actually supposed to be looking at, right?
Exactly. Yeah, we absolutely could. It's right. So right now, kind of the work we've done has been mostly around expression stuff.
Yeah.
So I don't know if you kind of can see this, but that's the kind of the tracker we use right now. It's based on top of sort of the state of the art of face tracking, which is called the constrained local model. And we just use the outward camera to basically take that shape no matter how I'm looking and normalize it at pose and scale. such that the emotion is not dependent based on how close I am to you and what kind of my pose is.
Right.
And then we use that to kind of use a geometric approach to figure out, oh, you're surprised, you're happy, those sorts of things.
Now, how, does it show up on screen that it senses that you're happy or sad?
Oh no, we have stuff of that on glass. Which,
okay.
We can show you on the glass.
Yeah.
But a lot of that, sort of the state of the art of emotion recognition right now is about as accurate as a 3-year-old.
Yeah.
It's not as accurate as a psychologist, and we're focusing on kind of getting the 4 to 5 emotions that are kind of crucial to work really, really solidly.
Yeah.
And in real time. That's kind of a core requirement. We don't want you to post-process it, which is, oh yeah, I can use the most amazing texture-driven emotion recognition algorithm in the world. If you're giving me a 2-minute video and 30 minutes to process it, we want to do it in real time, on the glass, without having to go back and forth, interact with the server.
Now, this is not face recognition. This doesn't tell me your name when I'm looking at you. It just tells me, are you happy or sad, and gives me some social cues to help me deal with you, right? If I'm an autistic person.
Yeah,
That's really interesting. Once it gets hooked up with face recognition, if Google ever gets
exactly. So that's kind of the limiting factor
Yeah.
here. Is if we want to get more devices from Google to do beta testing, we start doing recognition stuff.
Yeah.
They're
Well,
not
they
gonna
already
be
said
good.
it's banned for
Yeah,
right now
exactly.
doing the recognition.
So-
But face detection like this, I've seen other companies do. They can already tell what age you are and whether you're male or female.
Yeah.
So now my autistic son always loves hugging everybody, right? And that puts him in danger because he can be preyed on by a predator. Well, here he could get a social cue. No, this is not appropriate behavior to exhibit with this person, right?
Yeah. I mean, that's something we're doing. Again, sort of the approach we're taking at that is right now it's been mostly a geometric one. So the idea there is that different cognitive features kind of are different person by person.
Yeah.
So not only is the shape in your face different, but also the way you move your eyebrows is different. The way you move your face.
Is this technology going to evolve to the place where I can tell if you're lying to me or, because a professional is looking at micro tells and how your eyes move and to tell whether you're telling the truth or not. Right?
It's gonna get a lot more. It's gonna have to get a lot more dense than that. Kind of right now we're looking at 78 points. We might have to look at a few more to be able to do that sort of stuff.
Yeah.
We're starting to get some stuff around the cheeks and stuff.
So could it help you play poker, right? And
Yeah, I mean,
is your friend lying to you right now or not?
That's things you might look at and kind of in a while from now. It's we if there's somebody out there who says they can do it, we would love to hire them.
Yeah. Wow. So right now it's an R&D project at Stanford, right? Or
No,
is this going to
we're-
actually be a company that
We are a company, and
Okay.
sort of our customers lie within the education space. So that's kind of off glass. As we started out as basically measuring what we call an engagement score, as to figure out whether people are interested in content on the screen or not, and adapt content based on that. So our original vision was, I was in a flipped classroom class at Stanford. We would have to watch lectures before coming to class, and it sucked because it was boring,
Yeah.
and because instructors didn't get feedback on how bad it was.
Yeah.
So what we did was we basically built a way, for you to watch a video using an iPad or an iPhone or whatever. And if you're drifting away and you're not paying attention, the thing will ask you a question. Depending on how you answer the question, it'll jump to a different sequence and explain a concept that you've missed. And in the same way, it also aggregates that data across all the people viewing the content and provides that back to educators. So that's kind of the market we have traction and customers in right now. And as part of that, we realized, we just built very, very lightweight face tracking tech that worked on an iPhone and a cheap Android phone. Why not get it to run on glass? And it turns out, oh yeah, we could do that.
It's really interesting meeting guys like you who are trying to see extra signal in the world and trying to use the existing sensors to see that signal. I think that's really interesting stuff. It's going to be an interesting part of the future. I think Google's building a whole contextual OS, and having those signals of people around you, are they happy, are they sad, can feed into the OS of the future that'll tell the system? What kind of crowd are you at?
Yeah.
Are you having a conversation? Are you just at a bar where everybody's happy? On and on. I think that's going to be an interesting thing to watch.
So I mean that's kind of our play. We want to build in the long run. We want to build a more visual interface, and there's going to happen a lot around kind of the sensors integrated into devices. We're going to probably see depth cameras built into tablets at some point.
Yep.
We're probably going to see IR cameras that are going to allow us to do more accurate stuff with gaze in terms of where you're actually looking. But we see computer vision as a key component to determining how you respond to the device you're using.
Yeah.
And we think computing as a whole needs to get a lot more effective. Like a touch screen is pretty close to a good and natural interface, but it's still miles far away if you think of how computing could be if it actually responded to your mood and the way you felt about things.
Could this be turned into a new kind of dating game?
I mean, it's not,
Because I could be getting points for, making you happy, making you smile. I could get anti-points if you're like, that's a stupid joke,
So part of that is going to be kind of left up to all the developers in the world who are going to imagine this sort of stuff.
Yeah.
That's probably not something that we're going to build right now.
Yeah.
But
Are you building this as a platform then?
We're building it as a platform.
So
yeah,
I
we
could
have
add this technology into my app. And
Yeah,
then,
we haven't. We haven't formally announced anything there yet, but we
Yeah.
have a.
It's early
our,
days.
Our current customers use an iOS SDK, for instance, and a web SDK to do this sort of stuff.
Yeah. Well, it's going to be fun to watch what you guys do, and thanks for coming out.
All right,
and
thanks a
show
lot,
it to
man.
me. Where can I watch your work as this evolves?
Well,
Are
so
you
we're
on Twitter?
Yeah,
Facebook,
I'm on
or-
Twitter at myhumbleself.
Okay.
I'm at Senshin.co, Facebook.com/Senshin Technology.
Very cool.
That's
Thank
where
you
you
so
can
much
follow
for
us.
coming out and showing this.
Thanks a lot.
So this is the kind of stuff we're seeing over the next, there's one day left, right? We're doing a contest in the morning where we're going to give a developer $10,000 for having the best wearable technology demonstration. And we're seeing different innovators, different companies showing us what the future could look like from TechCrunch Disrupt 2013. Thanks for joining us. We'll be back in a little while, half an hour or so, with another interview.
Seeing into the future live. Rackspace's continuous coverage of TechCrunch Disrupt 2013 will continue in a moment. You've got code to write. Let us manage the rest. Find out more at Rackspace.com.